Howdy, y'all. Tip my hat to you for sticking with me. Let's keep on going with these means before spring break, that is. We covered intervals. So now I need to show you how to do some significance tests. So my idea here is to do a little side-by-side graphic organizer. We're going to have on the left the formulas that we did right before spring break, and then going down the right is showing you the new formulas. Now, it should all be kind of easy, I think. Means are a little bit easier than the proportion formulas. So, all right. Starting it off, we've got on the left our t-intervals. All right, so those t-intervals, that was when we had our net. All right. I'm getting really good at drawing nets. How about you? All right, so with these nets, we were able to capture the truth. Capture the truth. So we don't know what the true value is, right? In this case, it was a mean. So X bar was holding the handle and we're trying to capture mu. All right, so we use these samples to try and figure out what the true value is for the population. All right, so when we start these off, t-intervals, capturing the truth, we started off with a definition of what we were out to capture. And we were capturing means. So mu is the true mean. And I'm going to do a little dot, dot, dot here. And this is where you would put the context in. So whatever your problem is about, you describe it in the setup of your problem. All right. So the new piece that we're going to learn over here is going to be your t-tests. All right, so with the t-test, we have a magnifying glass now. All right, so that magnifying glass is looking for evidence, right? We're looking for evidence. Looking for evidence. So when you start to see these problems all thrown together, you're going to look for keywords like this, evidence versus what is the true value. All right, so that's how you'll know which one you're doing. So if you're looking for evidence, you're going to be getting a p-value out. The p-value is the probability of your sample happening. So the smaller the p, the more significant your sample would be. So let me add a little bit here. All right, so this p-value is answering the question, does our sample beat the odds? I'll put in parentheses, is it significant? All right. So just like t-intervals, your t-tests over here are also going to start with a definition of what we're out to investigate. This chapter, this unit 7, is all about means. So we should see mu everywhere. Okay, so mu is going to be the true mean and whatever the context is. All right, and then here's where the two different inference procedures part ways. Your t-test has a little bit more that we have to do, whereas the interval, not so much. All right, so on a t-test, we have to define what our null hypothesis is and what the alternative hypothesis is, and we also have to declare what our significance level is, right? What will we consider significant? Okay. So your null hypothesis, make sure you're using parameter symbols here. So mu, there's no X bar. So mu equals blank. And then here you'll have mu, it could be greater than, maybe less than, or two-sided, doesn't equal to blank. Grab another color. Whatever number you put here, it's going to be the same number here. All right, it's got to be the same number in both of those spots. And I also want to remind you that your word problem is going to give you an X bar. Don't put that here. X bar does not belong in the hypotheses. Instead, what we should see up here is the claim. Let me see, I could put it right here. All right, so what is the claim in the problem that we're assessing? X bar does not belong. All right, X bar comes in later. Your alpha level, most of the time, it's going to be a 0.05. So if you get a sample that happens less than 5% of the time, that's usually significant. But that has wiggle room. You just want to read the problem and see what it is they want from you. All right. So Let me zoom it out, and now things kind of come together for both of these. They have the same conditions, so that'll be helpful. I'm going to do one giant condition section. All right, so the conditions are the same for both of these. The first condition is, of course, random, right? We want that data to be random. And usually we say it's stated. If it's not stated, then we have to assume it. So it's stated or assumed. We want to see things like SRS, or maybe they did stratified or cluster, some type of randomization for their data. Convenience sampling, voluntary sampling, woo, that's a no-no. We can't do inference on that type. All right, the second condition is your normal check. With proportions, we had the discount normal check with Jake from Stat Farm, not with means. All right, with means, we want to have that central limit theorem coming into play. So let's see. I was going to do like an ABC list. I'm just going to do a little dash instead. All right, so by CLT, the central limit theorem, we want to have a sample of at least 30. So if your sample size is at least 30, then you're going to be okay. If it's not at least 30, don't fret, right? We're doing T intervals. And if you remember this chart right here, this is telling me T distribution that there are many different types of T distributions. There's only one Z, right? So Z was this bottom row. But T, there's many different types of curves. So why am I getting into that? Well, T distributions are more robust, meaning they have more space out in the tails. So if there's a little bit of a skew, right, if your curve is leaning a little left or a little right, that's going to be okay. But what we don't want to see is a big gap and then an outlier. That's a problem. All right, so let me write down all these thoughts that are running through my mind. We've got central limit theorem. Hopefully that works. If we don't have a sample that is at least 30. So if sample is less than 30, graph the data to check for outliers. To check for outliers. All right, so I'm going to put in brackets here, T distribution is robust, which means it's okay if there's a little bit of a skew, but we don't want to see a big gap and then an outlier. So if our sample is not 30, graph the data, check it out to see if it's safe to proceed. And then let's see, the third option could always be, hi, I'm normal. Sorry, it's hard to see with these glasses. Hi, I'm normal. Okay, so the normal check, maybe it is a little bit complicated. Central limit theorem, or graph your data, or it says, hi, I'm normal. So these are three different ways that you can try and verify that it's safe to proceed. All right, so safe to proceed. And then the third one is independence. All right, if you are sampling without replacement, you want to make sure that you don't double dip. To make sure that you don't double dip, there's this 10% condition. And it's the same one we've been seeing over and over and over. You multiply your sample by 10, and you want to make sure that that number doesn't go any larger than the population size. All right, that kind of guarantees, well, nothing's guaranteed, but it helps us to make sure we're not sampling too many people in a population. All right, so once you check those conditions, then we start to separate again for our formula work. All right, so before break, we were doing intervals. So we were trying to capture mu, right, the true mean value. We used X bar as our point estimate. Then we had to get the margin of error, that wiggle room, using the critical value, which is T star, times the sample standard deviation, but we have to adjust it based on the sample size, right? Stats diet. All right, so a little bit of vocab here. This is your point estimate. T star is your critical value. And then this is your standard error. All right, it's not technically a standard deviation because we're taking the standard deviation and we are adjusting it for our stats diet. So we call that standard error. If you look at the critical value times the standard deviation or standard error, this has a name. It's called margin of error. So whatever you're adding or subtracting from your point estimate, we call that the margin of error. Okay, so friendly reminder, t distribution, there's many, woohoo, different t distributions. So we have to make sure that we list which one we're using. And that's the degrees of freedom formula. So underneath this, you want to show which curve, right? Which t curve did we end up going to get our t star. All right. So then you'll get your interval. It's on your calculator. Let's see, T.I. Joseph. Which one is that one? Step World Test. This is an interval for t. So t interval. This is number 8. So you could go to number 8 on your calculator to get your final answer. All right, so final answer with your sentence. We are blank % confident the interval blank to blank captures the true mean, and then whatever the context is that you started this problem with. Remember, these are nice little sandwiches. Whatever your opening line is up here, you're going to use that down here for your closing line. All right, so that was before break. Now we're over here with our hypotheses. All right, so the formula here to see if we have significance is a t value. It's like a z-score. We'll call it a t-score. How about that? All right, so our formula will be, where are we on the standardized t curve? So here's where we finally use x-bar, finally. We didn't use it up here. We didn't use it in here. All right, so x-bar finally comes into play right here. One shot, one little roll. Okay, so we want to see how far away our sample is from our null hypothesis. So I'm going to use a little 0 here to notate that that's the null hypothesis, the claim that we have up here. So how far away is our sample from the claim, and how many standard deviations is that? But we have to fix it based on stats diet. All right, so this is going to give us a value on the curve. Remember, 0's in the middle, and how many jumps to the right? 1, 2, 3, my baby don't mess around. There we go. So we'll figure out where we are on the t curve. Make sure you list off degrees of freedom. Which t curve are you on? Because there's many different t curves. Your calculator then is gonna finish this for us. So Step World Test. We're doing, oh, look at that, it's right at the top, t-test. So this is number 2 on the calculator. When you do number 2 on the calculator, it's going to give you a t-score. It's going to give you a p-value. And with that p-value, you're able to decide if it's significant or not. So remember, you're going to get a p-value. You compare it to your alpha, right? You're asking yourself, is my p-value smaller than the alpha? If you say, yes, my p-value is smaller than the alpha, then we get to reject the null hypothesis. Let's be proper. If our p-value is not smaller than alpha, then we don't have anything significant. We would fail to reject the hoe. Fail to reject the hoe. Remember, we never ever accept the hoe. All right? We only fail to reject the hoe. We don't have evidence right now, but that could change tomorrow. All right? If I take another x-bar, hey, maybe I'll have the evidence. Okay. So we showed the substitution. We've got our graph going. We shaded wherever we are on our t curve. Number 2 on the calculator gives you all the details. And now you're ready to write your concluding sentence. Alrighty, I think I might run out of time because I only get 15 minutes on this video. So you might have to look at the PDF version to see what this concluding sentence is. All right, so we have blank evidence. So either we have sufficient or it's insufficient evidence at